Hello class, today we're looking at triangle congruence proofs. Your essential question, how do I write triangle proofs? Your learning intention, I am learning to write proofs using triangle congruence. So for the warm-up question it says, find all the missing measures. A tower crane is used to lift steel, concrete, and building materials at construction sites. The figure shows the horizontal beam of a tower crane in which triangle ABG is congruent to triangle BCH, which is also congruent to triangle HGB. Is it possible to determine the measure of angle GBH? If so, how? If not, why not? So, pause the video and see if you can work that problem out. Well, I hope you tried. So let's get started looking at what is congruent. Okay, I know angle A is congruent to angle B, and it's also congruent to angle H. So if A is 59, then B has to be 59 degrees, and H has to be 59 degrees. If I'm looking at angle C, C is 27. C is in the middle. So that means that this one's going to be 27 degrees, and 27 degrees. Okay, if I'm looking at GBH, that's the third one here. Can I find it now? How? Using the triangle sum theorem. The triangle sum theorem states that the sum of the interior angles of a triangle adds up to 180 degrees. We have two of the three, so we can now subtract. 180 degrees minus the sum of 27 degrees plus 59 degrees is equal to. So as I'm looking at this, 180 minus parentheses, 27 plus 59 parentheses. Whoops, I added a plus. It is 94 degrees. So the remaining angles are all 94 degrees because you've got three congruent triangles. Okay, a member of the construction crew claims that segment AC is twice as long as segment AB. Do you agree? Explain. Okay. Okay, I'm looking at segment AB and segment BC. If you look at the congruence statements, what do you notice? Those are both the first two letters of the triangle congruence. So if they're the first two letters, that means that those two segments have to be congruent. So, because triangle ABG is congruent to triangle BCH, segment AB is congruent to segment BC by CPCTC. Since the two segments make up segment AB, then segment AC must be twice as big. So that was what we would call a paragraph proof. We start off with what we know about congruence, and then we add to it. So that was our two warm-up questions. I hope you were able to, even if you didn't do the proof, I hope you were able to think about it. Because we know these, AB is the first two, BC is the first two, HG is the first two. All three of those segments have to be congruent. And since the two equal segments make up the whole piece, we know that it has to be twice as big. Okay, now, we're going to start with the triangle proof. As we do this, we're going to mark what we know. So we know that FJ is congruent to GH. Tick marks show that those are two are congruent. Angle JFH is congruent to GHF. We want to prove that these two segments are congruent. So now, we know we have the first statement and reason, we have the last statement. The first statement and reason is what you're given. And this is your given information. The last is what we want to prove. Segment FG is congruent to segment JH. So we've got that much of the proof done without doing anything else. So part of this is filled in for us. Statement 2 says that segment FH is congruent to segment HF. How do we know that? We're saying that this segment is congruent to itself. What property is that? If you can't remember, think about what you see when you look in the mirror. You see your what? Reflection, reflexive. Okay, that's your reflexive property. Okay, now, it states that we can now prove two triangles are congruent. What two are they? Well, if we want to go in order, we could go JFH. So that's 1 and 2 and none. So GHF, 1, 2, none. But why? What congruence are we using? Side, angle, side. Okay, if I go to all that work to prove two congruent triangles, what will be my next reason? CPCTC. Anytime you prove congruent triangles, I can almost guarantee you the next reason will be CPCTC. If you have any questions, back the video up and look at it again. Okay, now, this doesn't have very much filled in at all. So, we do know that AB is parallel to DC. To show that they're parallel, we use those little arrows. Remember, we're always going to fill in what we're given. That way we can look and understand what we're seeing. And we know that angle B is congruent to angle D. Now, what else can we prove? What we want to show is that segment BC is congruent to segment DA. And we start with segment AB is parallel to segment DC. Angle B is congruent to angle D. That's your given information. Okay, how do we know angles 1 and angles 2 are congruent? What kind of angles are they? We have parallel lines. Are they interior or exterior? Well, they're in between the lines, so those are interior. Are they same side or alternating? They're alternating interior angles, and we have proven that they are congruent. So that is by alternate interior angle theorem. And I always shorten theorem down to THM. Okay, so we have two angles that are congruent. Is there anything else between those two triangles we know has to be congruent? Because we're wanting to prove triangles are congruent. Can I prove a line segment is congruent? Yes. Any segment is congruent to itself. So segment AC is congruent to segment CA. That's your reflexive property again. Okay, which two triangles are congruent? And how do I know that? Well, triangle ADC is congruent to triangle. A doesn't have any, then we've got B, and I should have put two tick marks here so you know that these are not necessarily congruent to D. So ADC will be CBA. Okay, this is by angle, side. Now, I've gone to all that work to prove two congruent triangles. What am I going to use next? CPCTC is correct. Okay, for the last one, we have segment QK, that's this one right here, is congruent to segment QA. And we know that QB bisects angle KQA. So now, we have to think, what does the word bisect mean? So bisect. Bisect means to cut into two congruent pieces. So we know the larger angle is cut into two congruent pieces. So let's get started. We get started with what we are given. And we can fill in the last statement because we know the last statement is what we want to prove. We are given that QK is congruent to QA. So QK and QA are congruent. They're marked. We're also given that segment QB bisects angle KQA. That's our given information. Now, our fifth statement, our last statement, will be what we're wanting to prove, which is KB is congruent to AB. So, we've marked the congruent ones here. Now, we know that bisects means to cut into two equal pieces. So, which angles are now congruent? Here's your bigger angle. So we know that angle 1 is congruent to angle 2. Why? Definition of bisects. Bisect means to cut into two congruent pieces. That's the definition. Okay, so we've got one side, one angle. Next, we're going to use the reflexive property of congruence. Reflexive means it is congruent to itself. Segment QB is going to be congruent to segment BQ by that reflexive property. Now, it says that we've got a triangle congruency here. What is it? Look at the picture and read it like from one to the next to the next. So if I start here, this is side, angle, side. Side, angle, side. So now, which two triangles are congruent? If I go KQB, will be congruent to triangle AQB. And that is by side, angle, side. Once again, I've gone to all that work to prove two congruent triangles. What comes next? CP-CTC. So, by CP-CTC, those two pieces are congruent because they're the corresponding parts of congruent triangles. So, how do you know when you're successful? I know I'm successful when I can complete triangle proofs. So these are triangle proofs.